So now in this video we're going to look at a circuit where we light 5 red LEDs. So they have a forward voltage about 2 volts each, just kind of flickering because I'm bumping the power supply right there. If you bump it right, it cuts power briefly. But in any case, 5 red LEDs, they take about 10 volts just to conduct and light pretty well right there. So I'd like to keep like 12 volts across them, no matter basically how high the supply voltage goes. Of course, if you go too high, something's going to overheat. So we're going to work with between 12 to 20 milliamps of current. But we want to, keep kind of close to like 10 milliamps of current going through the red LEDs. So we got a 150 ohm resistor. Again, trying to keep 12 volts across that. Now, we have a 12 volt Zener diode there. You use Zener diodes reverse bias. So the black band, the cathode, is actually more positive. The side without a band, the anode, is more negative. That's backwards from a regular diode. This is how you wire a diode when you don't want it to conduct, but Zener diodes are specially made so that when you reach a certain voltage, they do conduct safely, as long as you limit current. And so this is a 12 volt Zener diode. It's going to start conducting at like 12 volts. What that means is that we can maintain about 12 volts at the base right here. Now it does go up a little bit. That's going to work in our favor at higher currents. And hopefully it'll be a little bit above 12 volts, because if we have like 12.6 volts there, then we can expect a transfer of about 12 volts over there, because the NPN bipolar junction transistor is wired as an emitter follower. So there you can see we got the collector to the positive supply. That makes it a common collector. The collector is going to a supply voltage. And then we got the emitter. Following the emitter is our load right there, emitter follower. And ultimately what that does is this load, prevents, current freely flowing from base to emitter there. And ultimately what it does, whatever voltage we build up here gets, transferred to here. This can't provide, maybe this particular one could, but usually the base doesn't have enough available current to provide power for the load, but it doesn't need to. A little trickle of current, base to emitter, allows a lot more collector to emitter current, and then through the load right there to flow. So as long as the voltage hasn't built up enough to, stop any more current flowing from base to emitter, the voltage is going to rise until it's about 0.6 volts, because you have the base to emitter diode drop right there. Hopefully that makes sense. So as long as we keep, about 12 volts across this circuit, let's say we get up to a 1.5 volts. That could kind of be expensive. They're expected. You can see 1.5 volts divided by 150 ohms is about 10 milliamps of current. And so we want to maintain, like 1.5, maybe 2 volts. Doesn't matter. Current will just go up slightly. Main thing is that we'll keep current limited through the LEDs, even with a massive supply voltage change. So I will pull back. And one thing when we're looking at the power supply is that it is adding up the current through the LEDs, transistor LED there, as well as the current going through the 1K resistor and the Zener diode. So the Zener diode drops about 12 volts, so probably almost no current going through the 1000 ohm resistor right now. But when I raise this up to 20 volts, so the LEDs should, they'll get like a speck brighter, but they didn't get a lot brighter right there. So we got 20 volts. The Zener diode is dropping about 12 volts. That puts about 8 volts across the 1000 ohm resistor. Almost all of it also going through the Zener diode, the current, I mean. And so probably about 8 milliamps of current is going through the resistor and the Zener diode, leaving about 10 milliamps of current going through the LEDs right now. You can see their brightness is not really changing, other than when we start getting kind of a lower voltage, because, you do need a certain amount of voltage to keep this system running. So, since this was a pretty simple video, we might as well take a multimeter measurement. So, we're going to go to the milliamp range. Very important that you set it to the right setting. If you have numbers, set it to a number higher than what you can expect to measure. So, as we saw in here, maybe we'll get like 20 milliamps of current, but no more than that. So you could set it to like 20 milliamps if there's numbers, but all we have is milliamps there. I think this only goes up to 600 milliamps, so So it's not anything less than an amp. Be aware of that. I don't have to move the red probe for anything but high current in the amp range. So I'm going to plug this, probably more than like half of a amp, probably. You should use the amp setting, but we're not going that high. We don't have to worry about it. So right now, the supply voltage is 12 volts right there. And maybe I can hold this with one hand, where I can take a measurement while I am changing the voltage. But again, at 12 volts, we saw a power supply set about 7 milliamps of current right there. It is not as accurate as a multimeter, as you can see right there, but you know, it's close. And so a little bit above 7. It was 7 before. So I'm surprised it's a little bit lower. But again, it's not as accurate as a multimeter, and the multimeter is going to take away, you know, a tiny bit of current. But there you can see, I'm raising the voltage. So voltage has gone up a lot, but current, you know, not a ton right there, because it's mostly maintaining the, you know, voltage across the load for the most part. You know, it does change like a little bit. But there you can see, now we got 20 milliamps current, and instead of about a little bit above 7 milliamps current, now it's, you know, like 10 milliamps of current. Current is going to go up as these semiconductors warm up, but at some point they will level off. So that's why it's, you know, continuing to trickle up right there. That's, if you don't limit stuff, ultimately the resistor is going to keep things in check at some point. But if you don't limit things, semiconductors tend to conduct better as they warm up, unless they're specially made to conduct less as they warm up. But that's something to be aware of. If you don't have something ultimately limiting the power at some point, which the resistor does here, you could overheat things. That's a possibility. So yeah, we looked at the voltage rising over time. Now I'm going to put the jumper back. So we saw, you know, there's more current on the power supply than just what the load needed. I missed an LED. That's the problem there. So now what we're going to do is let's go back to 12 volts and just, you know, keep things from, you know, getting like real hot, whatever, because I'm starting to touch them, pluck them and stuff. So we are going to, we have to move the resistor. We need the Zener diode here to limit the voltage. If we remove the Zener diode, that's my body giving a false signal. If we move the Zener diode, then we would have had 20 volts if that was still 20 volts. And that could have damaged something. We don't want to do that. So now this is connected over there. We are going to measure the current that's going through the resistor. So now it's got to go through the resistor and then the meter right there. And there you can see it's practically no current. It's barely registering it. We could go to the micro amps, but we're not going to. And so now I'm just going to go right up to 20 volts right there. And again, no current is showing on there right now because we don't have any current going through the transistor until I complete the circuit with the multimeter right there. So yeah, there you can see, you know, somewhere around 8 milliamps of current right there. Looks like a speck less. You know, that's okay though. But we're 8 volts above 12 volts. So that's to be expected. It's a 1000 ohm resistor. So for each volt across it, we got about 1 milliamp of current going through it right there. So you can see that lines up with the power supply pretty well. The current going through there plus the current going through there. Whenever you have parallel circuits, so we have, you know, it's all one circuit here, but we have parallel components basically. This resistor and that diode are mostly parallel because a little bit of current does like trickle over. But the two of these are mostly parallel with that circuit over there. So we got, you know, somewhere around 10 milliamps of current going through there and somewhere about 8 milliamps of current going through there approximately, for a total of about 18 milliamps of current. Hopefully that makes sense. So now we have the power, the multimeter, I mean, right here, measured, set to measure current. Power supply is limiting current to 20 milliamps. So if I did accidentally measure these, we would not fry the multimeter. I'm not going to do so, but we could press that and probably going to say about 20 like milliamps current or something. But the power supply is going to sense that we got current going directly from the positive to the negative because the power multimeter doesn't really provide any resistance, you know, just a spec. So this will think it's a short circuit and auto shut off. And so I could demonstrate that, but I'm not going to. Any case, you don't want to measure a voltage with the multimeter when it's set to measure current. That's a really easy way to blow a fuse within the multimeter. So you just replace the fuse or whatever. Not, you know, a terrible deal, but it is kind of a pain. It's best just to, especially get it off of measuring current. Maybe you could set it to measuring voltage, because it's always safe to measure a voltage. And since this has a dial that goes to off, I'm turning it to off. If there was an off button instead, I would set it to voltage and then turn it off. That's just a tip I try to share in all my basic videos, when basic circuit videos that I add a multimeter. And also, I usually have circuits that need 5 volts or less, or 5 volts and no more than 20 milliamps of current. So I try to set the power supply to that. So I did that. This isn't powered. When I notice I got this circuit, it's not powered, I'll think, okay, I got to turn the power supply on, and I'll notice it's only 5 volts, so I'll know I'll have to raise it. But we're not going to worry about that right now. It's safer just to always put the power supply at 5 volts, so I don't fry something when I wire it up thinking it's only 5 volts on the supply. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help a lot. I'll see you in the next video.